In this video, I am going to explain you the types of optical fiber. So as you all know that optical fiber is made from basic three elements: core, cladding, and buffer coating. The material which is used for making the core and the cladding are plastic and glass, and both of these material have different refractive index. So while designing the optical fiber cable, it is important to note that the refractive index of the core should be greater than the refractive index of the cladding. So based on the material, there are the three types of the fibers are made. Three types of the fibers are made. This is the first one, this is the second one, and this is the third one. In first, core is made from the plastic material, and cladding is also made from the plastic material. In the second case, the core is made from the glass material while the cladding is made from the plastic material. And in the third case, core is made from the glass material and cladding is also made from the glass material. So, as we are using the different material, the refractive index of the core changes. So, depending on that, there are the two types of the optical fiber. The first one is the step index optical fiber, and second one is the graded index optical fiber. In step index optical fiber, in step index optical fiber, as you can see here, this is the core, this is the core, this is the cladding, and this is the axis of the core. This is the axis of the core. Okay, so as you can see here, this is the diameter of the core. This is the diameter of the core. This is the diameter of the cladding part. This is the diameter of the cladding part. So here the refractive index of the core is uniform throughout the region. It is not changing. It is not changing. The refractive index of the core is uniform, and the refractive index of the cladding is also uniform. So when we connect these two profiles, when we connect, we get the structure like the step, and this is known as the step index optical fiber. In this, the bandwidth is very large. So as you all know that uh, when the light passes from the denser medium to the rarer medium, the angle of refraction bends away from the normal. Okay, so and when the incident angle is greater than the critical angle, then the light gets refracted inside the denser medium only. So as you can see here, the phenomenon of total internal reflection happened here, and light is traveling in a zigzag path. And here it is important to mention that the refractive index of the core is greater than the refractive index of the cladding. Second is the graded index fiber. In graded index fiber, as you can see here, the refractive index is not uniform, it is changing. Here, this is the axis of the core, this is the axis of the core, and this is the core, this is the core, and this is the cladding. This is the cladding. So you can see here, this is the diameter of the core, and this is the diameter of the cladding. And here you can see that the refractive index is maximum at the axis of the core, and it is decreasing as we are moving toward the perimeter of the core. Here you can see that this is decreasing. So why it decreases? Because the core is made up of the concentric layer of different refractive index fiber. Means, as you can see in this diagram, the core is made from different refractive index materials. Here you can see this is the different refractive index. This one have the different refractive index, and this one have the different refractive index. The first one, the one that is present at the center, have the refractive index of U1, and the second one, which is present just after this, have the refractive index of U1 dash, and the third one, which is present after this U1 dash, the refractive index of that is U1 double dash. So it is important to mention that, as you can see here in this diagram, the axis the axis the axis of the core have the higher refractive index. So here this is present at the axis, as you can see here. I am showing you, this is the axis, so it will have the higher refractive index. So mu1 is greater than mu1 dash because it is decreasing as we move toward the perimeter. So mu1 is greater than mu1 dash, and mu1 dash is greater than mu1 double dash, and mu1 double dash is greater than mu2. Mu2 is the cladding. So we all know that mu1 should be greater than mu2 while designing the while designing the optical fiber cable. It is important that we consider the refractive index of the core should be greater than the refractive index of the cladding. Because of this, uh, the signal when passes through the optic fiber cable, it travel in sinusoidal form. Here you can see that. Focus on this diagram. When than the refractive index of the cladding. Because of this, the signal when passes through the optic fiber cable, it travel in sinusoidal form. Here you can say that. Here you can see that. Okay, focus on this diagram. When light, when the light signal comes here, then it will pass through the air, and you can see here that the refractive index of mu1 is greater than refractive index of mu1 dash. So you all know that this is the denser medium. Now this is the denser medium and this is the rarer medium, and when the signal passes from the denser medium to the rarer medium, then it moves away from the normal. So here you can see in this diagram, then the signal will pass like this. So after this, when so after this, mu1 dash will act as a denser medium, and mu1 double dash will have the rarer medium. So same procedure happens here. Signal will pass from denser medium to the rarer medium, and it will move away. The refraction angle will take place away from the normal. So it will come here like this. Now here the total internal reflection will take place, and signal will get refracted inside the denser medium. Now like this happens, and we get the sinusoidal waveform. So here you can see that the light signal will travel in this form in optic fiber cable in graded index fiber. There are two types of the mode present in the fiber optic. First is single mode and second is multiple mode. And I will explain these two in deep in the next video. So let's focus on the step index fiber. So basically there are the two type of this step index fiber. First is single mode step index fiber and second is multi-mode step index fiber. So to explain single mode step index fiber, imagine that we have one lane, consider this as one lane, and this is the car which is traveling through this lane. Consider this is very narrow lane and only one car can go at a time. So in this, consider the car as a laser signal and lane as a path which is used by the car to travel from point A to point B. So in our condition, in single mode step index fiber, here mode means the path which is used by the light signal to travel from optic fiber cable. So in single mode step index fiber, only one path is present. Only one path is present. This means only one signal can pass at a time. And here the step index, it is a step index fiber. This means that refractive index will remain uniform throughout the fiber optic cable. And here it is important to mention that the diameter of the core is 18 to 12 micrometer. This means that it is very small, and it will require high fabrication cost because of the small diameter, and the diameter of the cladding is 125 micrometer. And this type of the optical fiber cables are used for the long distance communication, and single mode step index fiber have the higher bandwidth. And in multi-mode step index fiber, to understand multi-mode step index fiber, now let's consider that lane there are the multiple lane, and multiple car can go at a time. Consider this as a car and consider this as a lane. Now consider this car as a light signal, and consider this lane as a path. This is lane, and this is the lane. This Consider this as a path. So in multi-mode step index fiber, there are the multiple paths are present, or with the help of this path, multiple light signal can travel at a time. As you can see here, it is a step index fiber, so the refractive index of this optical fiber will remain the uniform across the optical fiber cable, and the diameter of this multi-mode step index fiber is 50 to 200 micrometer, and the diameter of the cladding is 125 to 400 micrometer. So basically here, uh, multiple light signals are traveling at a time, so the effect of dispersion take place. This means the loss of the signal will happen in the multimode step index fiber, and here the bandwidth is not very large. So this type of the fiber, multimode step index fiber, is used for the short distance communication. This means this type of the optical fiber cables are used in the offices for the communication. The third one is the multimode graded index fiber. Here we can say that graded index fiber, this means that our refractive index will change. Suppose this is the axis of the core. So as we will move toward the perimeter, the refractive index of the core will get decreased, and we have the maximum refractive index at the axis of the core, and as we move toward the perimeter, the refractive index will decrease. As I have explained earlier, the signal travels in the form of the sinusoidal path. As you can see here, this is the multimode, so multiple signal can travel at a time.